morning, everybody. A few words of introduction to perhaps get us started. My name's Flynn. I run a company called Artificial Solutions. I think we're perhaps atypical from the companies that are here presenting in that we're not so much to do with the physical operation and safety and focus on the autonomous operation of the vehicle. We operate in a slightly different area. To be specific, we are a software company focusing on natural language interaction. Natural language interaction being the bi-directional communication between people and technology, using the native language of the human, okay? And of course, that means many different languages. In our case, we already operate in 35 different languages. And we've developed a software platform, which is known as Teneo, from the Latin to understand, which targets the use case of building natural language interaction applications. So I'll talk a little bit more about that later, but clearly we're here very much focused on the automotive sector. And as you guys know better than I do, the automotive sector is in the middle of something of a seismic change in the expectation of how vehicles will be used in the future. And of course, once we get to the situation where the passenger no longer needs to focus on actually the operation of the vehicle, they can utilize the time that they have inside the vehicle with much more diversity than they can today. So it's, I'm not sure exactly how people are going to use vehicles, but they may well see them as places beyond the traditional infotainment zone that we have today into workplaces or party zones or exercise gyms or what have you, okay? And therefore, there is an explosion of use cases of how to interact with the vehicle. The number of what we call domains that will need to be supported extend way above the existing infotainment and navigation use cases and command and control of the vehicle of today into a myriad different use cases which the user has an expectation will be supported during their journey. And of course, the reason that we're here today is that natural language interaction as a capability is an obvious choice for handling that interaction between people in the vehicle. It's by far and away the simplest interface. And I can give you a concrete example of that. One of our customers in the US is a telco, okay, and they own a division which does home and personal security. And the way that they achieve that is they utilize IoT devices like smart switches, thermostats, video cameras, locks, and so on. And they come and wire up your home with these devices and connect them to a secure hub, which they monitor, okay? And like everybody else, they give their users a kind of mobile phone app with which to control it. But the system is pretty sophisticated. So you can set up rules like on weekdays only between midnight and 6 a.m., if you detect motion in the camera at the back of the house, turn on the porch light, set the video to record, and send me an SMS, okay? Now, we as humans can absorb all of that entire string very straightforwardly, but when it came to them building a traditional interface to their application, the smallest number of clicks that they could do to get that utterance understood by their system was 44, okay? So the power of natural language as an interaction is clearly demonstrable, and it's no big leap to take that use case to the autonomous vehicle of the future to see that you might want to give it sophisticated instructions of a similar nature, and you don't want to be bogged down with complex user interfaces either through a mobile phone or whatever else might be in the car. It is totally logical that you'd want to use a speech-driven interface to do that. And therefore, our thesis is that although clearly, whilst many of you are working in safety critical zones in the vehicle, the actuality of realizing autonomous driving in the future and some of the changes that come about are going to depend on a broader church of AI technologies, including natural language interaction. And of course, to us, although I understand not everybody's a native speaker of English, just in the same way as I'm an awful speaker of many other languages, the challenge of understanding language is complex, okay? Just to start with a very simple example, this is in English, obviously, but people choose a great many different ways to say yes, and believe me, this is not an extensive list, okay? So the task of actually identifying, the synonyms for an individual word itself is a very complex thing to understand. And it's slightly different to some of the more structured environments because language also has syntax, grammar, and people abuse those constantly. But the reality is that the user of the vehicle of the future is not just going to want to have a single utterance interaction with the vehicle. They're not even just going to want to give it long, dense strings like the one I gave you about the home security environment. What they're going to need to do is actually have a sophisticated and human-like dialogue with the car. And the reason being that this will constitute one of the ways that you will get things done with the car. Of course, navigation is an obvious example about where you might want to go and so on and so forth. But there may be many other use cases that could command the vehicle, and many other use cases which command other aspects of the vehicle. If the windscreen is going to become the monitor for your working environment and you're going to be processing emails through it, you're going to need to have a complex interaction and dialogue and understand the complexities of no, not that one, I meant the one on the right? And so you need a very sophisticated level of understanding of language at the core base, and you need to layer on top of that a dialogue management system. And it's our belief that it's going to be necessary to support this level of interaction in order to realize the promise in the automotive sector that you guys are working so hard on around autonomous vehicles and self-driving and so on and so forth. And of course, there's one interesting thing about this once it's applied, which is that the automotive sector, as you know, is simply massive in terms of users. So if each user is interacting with vehicles in natural language, they're going to be yielding huge volumes of interaction data from the vehicle in unstructured natural language. So this is going to be one of the best sources available to both the OEMs, the Tier 1 manufacturers, and other users of understanding the specifics of the user, the passenger of the car, in their own first-person singular language. And just as I said that actually understanding the language of the user is a challenge, understanding the scale of millions and millions of dialogues with people is beyond the human ability, okay? So naturally, we're going to have to find learnings through machine intelligence driven from these applications. And we believe that this offers something of a massive opportunity for the automotive sector. Specifically that as users interact with vehicles in ever more sophisticated use cases, they can learn more and more about the preferences, the frequencies, the domains that people want to experience inside the vehicle. And of course, this leads to many different beneficial outcomes for the industry. One outcome is that in real time, you can interpret this data relative to a given passenger and know perhaps automatically their intent, so that we can figure out through nothing more than having interacted with this driver that, well, you know what, it's around about 5 in the evening, he's hailed a ride-sharing car again from this location, and every other time he did that, he went to that location. So, you know, we can initiate a dialogue with the passenger around those lines, okay? And that we might also know that the first thing that they ask for is to see their email on the screen when they get in the car. So there is a huge wealth in order to personalize the experience for the passenger. But there's also a huge wealth of knowledge to be gained here by the providers so that they can improve both the domain coverage and the services that they provide to the passenger of the vehicle. And they will know where they're falling short, not just in terms of the physicality, but also the services that people might want. You know, who knows how popular, you know, online shopping is going to be in an autonomous vehicle of the future. So there's a huge wealth of information here that can be captured that the automotive industry can leverage to its own benefit. And I think that that is one of the key challenges in the industry of today. Is it, I mean, in the sense of natural language only, is it the case that the ownership of the interaction with the customer should be ceded to the technology giants like Microsoft and Apple and Google, or is it the case that the OEMs should build a relationship directly with the user of the vehicle and own the data? And we believe that it's very important that the ownership of that data resides with the provider of the service, and that extending that out to the large technology giants will enable those companies to gather enough data to become competitors to the OEM of today very readily. So we think that having natural language interfaces to the vehicle in a very sophisticated manner, being able to collect the data that comes from it and being able to interpret that data for the benefit of the user and the benefit of the OEM is a very critical part of making a differentiated experience for the autonomous vehicle of the future. At Artificial Solutions, we've been working on this problem for quite some time. This is actually a map of one of our language objects and its interrelations with other associated language objects, right? So there are just these dots. In English alone, we have 180,000 of those dots in our grid, okay? So it's a very complex problem to solve, and the technology that you need to do it, much like the technologies that I've heard people talking about here, relies on a great deal of data, relies on a great deal of horsepower, machine learning, tagging, and so on. And we have been doing this to a very high level of sophistication for a number of years. And the autonomous vehicle is a relatively new adventure for us in terms of use case, whereas language systems have been deployed in mobile phone, personal assistants, and so on for a number of years. But the learnings that we've gained from operating in the area of natural language are immediately transposable to the land of the autonomous vehicle. Many of the use cases inside the vehicle are, you know, identical to what people might want to do in a home environment today. So what we have built, and I mentioned this Teneo platform, is a full end-to-end platform that enables people to build applications. We provide a graphical environment which hides all the complexity of those linguistic maps from the user and lets people build out domain experiences, perhaps in infotainment, perhaps in navigation, perhaps in working environments, e-tail, whatever it might be, and mash them all together in one seamless user experience. We allow people to build these to their own specification, so that each vehicle or brand might have a different brand tone, have a different set of available features, have a different style to it. And of course, these can be deployed. And interestingly, our technology looks at two principal deployment models. There's one that seems to be much more popular in the US, which is the assumption that the vehicle is permanently connected to the cloud. So a cloud-based deployment. And there are clear advantages of that for our technology. The speech recognition service provided by a cloud-based engine is more accurate and faster than one produced on a local engine and has a larger vocabulary. Okay? So we can provide a better service if we have a connected environment. But equally, we've had to build our technology so that it can actually sit on board the vehicle as well and run in a disconnected mode. And that actually leads to an entirely hybrid experience where certain features can be done when the car is connected and certain things cannot. You know, tell me what the weather's going to be like when I get there is not going to be available if you have no connection to a cloud service. But you could say that and it would remember it, and then when it knew that it had connectivity, it could tell you what the weather would be like. And a hybrid deployment like that is probably going to be the most common interim solution until we perhaps do have ubiquitous connectivity. But living in the third world of telecoms in the UK, I can tell you that seems to be some way off. The rest of the platform allows you to deploy these at scale and then to collect the data that comes off it. And the data, as I mentioned, you know, as you can see from the complexity of our grid about natural language, is difficult to understand. If somebody says that word yes, is that a good thing or a bad thing? Yeah? Yes, I'd like to order. Do you want, you know, or yes, I'd like to cancel, are not quite the same thing, right? So we have to be conscious of the sequence of events in the dialogue, and we have to be able to understand the entire flows of conversation. And that is a big challenge in terms of computation and learning and so on. And the ability to analyze that is an integrated part of our platform. Not only to analyze it, but to leverage it in the way that I articulated before to provide a genuinely personalized experience to each individual user. Not just based on GPS data, time of day, and so on, but actually just based on pure play linguistic interaction with you. The important thing, of course, is that the vehicle is not going to exist in isolation. You know, the vehicle is still going to exist in the context of people having devices in the home, like Amazon Echoes, or maybe, you know, mobile phones or wearable devices. And it's obvious to us that people are going to want a seamless interaction from those technologies into the vehicle and vice versa. So whatever platform has to be able to support all sorts of different use cases, and indeed, we even think that specifically in the area of the vehicle, it might not be just cameras pointing outside, there might be cameras pointing in to understand the gestures of the user as well, so that they could point that one to the screen as well. So there could be all sorts of different deployment models of the solutions, even just ones that are designed to ultimately support the car experience. Okay, so it's imperative that you have a platform that enables you to seamlessly deploy the same natural language experience no matter what the user's front end is. Some of which may have no screen technology at all, like that Amazon Echo that I said. And of course, as I mentioned, the most important thing, the real prime asset as a defensive tactic for the vehicle industry in general, is the acquisition of data and the ability to understand that data, to use it in real time, or to leverage that data to improve products, to understand the customer's journey with you, etc. Because as an OEM, you would gain a lot of insight into your customers, both before the acquisition of the vehicle, after the acquisition of the vehicle, the servicing habits, and all of these other things. Of course, you've got many things that are coming off sensors today, and you've got telematics and so on, but actually the first-person singular voice of the customer is arguably some of the richest data that you can acquire and utilize to your benefit. And as I said, the real challenge for the industry in our minds is that today we've got all sorts of pervasive linguistic technologies hitting consumers' environments. I mentioned Amazon Echo, of course, there's Google Home and other things. There are existing autonomous vehicles, there's IoT, connected homes, and so on and so forth, all of which are yielding huge amounts of data for the solution providers. And the challenge for the automotive industry is to make sure that it captures that data through its own bespoke interfaces associated with the vehicle and the passenger in order to provide the same enrichment of experience. Otherwise, that data will be used against them to proliferate new entries into the automotive market. And we think that also there's a large component of the security of the data that needs to be considered, and also the protection of the data as well. What we know is that obviously there's a great deal of legislation about data, and of course that is probably only going to get more and more complex and more difficult. But we also know that against that, particularly younger generations are more and more happy to share data, provided they're getting a value-added service. Okay, so and this is a classic case where that data can be used to better understand, predict, and serve the needs of the eventual passengers of the vehicle. So that's just to summarize that then. We're here today as a software vendor in a perhaps unique place compared to the landscape of the rest of you in attendance. And we're focused on one thing that we think is going to be as key to the adoption of autonomous vehicles as the technology itself that enables autonomous vehicles. We have to make it usable, and we have to make it an environmental space that people can utilize the time effectively in any way they choose. And obviously, in order to achieve that, they would need to have a very intelligent interoperability between them and the vehicle. They need to be able to not just have single utterances of a command and control type, open the door, turn the aircon up. They need to be able to have fully conversational interfaces which are context aware and which can swap topics and domains and so on and so forth. All of this is going to yield a huge volume of unstructured natural language data that is tagged very specific to individual users. We have got some strange use cases at work at the moment where we're building solutions for buses, which has a great deal of complexity when you've got 30 users. But focusing predominantly on the smaller vehicle, the data is going to be very easily to tag to an individual. And it's not necessary that we need to tag that data to a vehicle, because the user could have multiple vehicles or use rideshare capabilities, and they can have their persona travel with them. So understanding that is very important to the hearts and mind ownership of the user of the future. And of course, it's a key to competitive advantage. The more you know your user and the more you know your customer, the better you can provide service to them. I mean service like we might traditionally provide, like genuinely service, aftermarket care, and so on and so forth. But also, we can extend the services that we offer to the user more and more through understanding what their requirements is. And, we think, obviously, just like you guys, many of whom are working in safety-critical environments, you have to do this with a very high degree of accuracy. And you have to do this with a very high degree of capability. And therefore, you need all of that data and experience that a company like Artificial Solutions has gained through handling billions and billions of interactions behind the scenes of lots of other enterprise applications. So that was all I was going to cover today. I'm happy to take any questions that you might have.
Thank you, Lawrence. And just, to put some real-world examples behind some of the things Lawrence just talked about there, I'll give you kind of 2.5. Tesla has talked about storing in the cloud all the customer data so they can get into any vehicle and it'll automatically understand them. Jaguar Land Rover is doing something similar, albeit with and maybe just for demonstration purposes, with a removable steering wheel that you can carry around. And the 1.5, if you go and look at BMW, they've not just kind of talked about it, they've also showed as a concept, both a Rolls-Royce and a Mini shared concept, actually, they did last year, where the The Rolls-Royce one is actually a natural language interaction with the passenger being told he'll go and take a detour to pick up his son's birthday present, whatever it is. And the Mini, as the passenger gets in, there isn't a language interaction in the video, but it is saying, I know you wanted to pick up where you left off on your Danish lesson or something. Right, so this is a real trend. So any questions for Lawrence? Go on, please, right in the front.
Thank you for your talk. For me, it's clear that we need this. Working for BMW, as already was mentioned, we are looking into this in particular ways. What I would like to know is, how do you measure your progress in this field, and how far along are you?
So, measuring progress is very much driven by use case, okay? So, there are a number of pure play metrics. So, we can measure the native level of understanding of a single string of utterance. Do we match that to the correct intent of the user and with the words properly identified? And pretty much natively, we achieve over 95% score in that regard. And when I say natively, we can enhance that score because many people, particularly in the automotive sector, might use language which is not kind of commonplace. So we have an extensible vocabulary that can learn as users use different branded experiences or model names or what have you as they come into vocabulary. So we can ratchet that up above that based on tuned vocabulary, and we can tune it for any domain. So of course you can tune it for the vehicle, and you might have a certain feature that you've branded a certain name. Or we could tune it for other domains like infotainment. So in the infotainment sector, for instance, music tracks and video names and so on and so forth, they're kind of complex to understand, and we have done a lot of training of systems in real-time understanding of those things. And in fact, that is a real complex challenge. So to give you a real-world field deployed example, in the home security environment that I talked about, they've got 1 million houses on this system. Each house is different. Each house has a different set of devices in it. Each house has a different number of rooms, all named differently. And each device can have a custom name. And we have to understand the topology of the house. When I say to it, turn the light on in Catherine's bedroom, would mean nothing in somebody else's house. Yeah? So we can dynamically absorb the vocabulary, which is very useful for things like mobile phone interaction for contacts and so on. It's great for music services. It's brilliant for infotainment in other areas as well, video gaming and so on. But so we can absorb that. We haven't got to 100%, but natively for common use domains, we can achieve a 95% understanding of it. More importantly is perhaps to understand whether you do a complete dialogue to task fulfillment. Yeah? Because just understanding the utterance needs a context. It might need interaction with other services that may or may not be available, depending on the cloud availability. And ultimately, you have to make sure that it is a service that you can provide, the extensibility of the model. And we have something called the network of knowledge that enables us to plug in additional services as they come on stream. And of course, we don't get as high a score in the complete task fulfillment, but we're still in 83-85% task fulfillment for in-domain experiences. Yeah.
And how do you measure that 83%?
So we measure it because we can track the entire dialogue start to finish. And like many other machine learning technologies, we measure it by initially hand tagging the dialogues to see exactly what the user experience is, and then we can learn from that and interpret the dialogue completion. We don't tend to use really crude measures like, are you satisfied with the service or stuff, because people are irritated by that in spoken systems.